Morning, everyone. My name is Ken. I'm the Senior Advisor for Low Carbon Solutions in Halliburton. So when Halliburton, we say low carbon, I cover geothermal, CCS, and also hydrogen. So the topic for today is more focused on the equipment. So we are talking about wireline logging. But the message that I would like to bring today, it's not only the tools, is why we do geomechanics. I think this is the very important understanding. And why is geomechanics, I wouldn't use the word different, I would use the word important, especially in ESG in the EGS sorry, there's a typo there, ESG so the enhanced geothermal system. So let me go very quickly now. For the wireline, now what we want to look at is the goal, right? The goal is very important. Everything we do, there's a objective and motive to it. So in Taiwan, definitely we are looking into increase the geothermal power production in the next few years. So this is the common goal that we look at. In the north of Taiwan, we have the Tatun Volcanic Group Mountain, where conventional geothermal is being drilled. So that is, I would call, the low-hanging fruit, the easy one. What we want to develop here is to increase megawatt per well, and also in places that there is no reservoir, with steam pocket. Now, how are we going to exploit this geothermal heat that we can actually convert into energy? Now, the goal here is to make sure that when we push forward with EGS, enhanced geothermal system, it relies on us injecting and then producing for it. Now, the important part here is to make sure that we have the, is it coming? Yeah, hydraulic fracture. Now, we are creating this fracture network through fracking. Now, here, of course, I'm going to link it to the tools that we're going to do. Here is part of the, I would say, exploration. You can say call it exploration. You can understanding the subsurface better through wireline logging. So it's going to help us in this EGS field development. It's going to help us in planning our hydraulic fracturing. And of course, geomechanics is not just about fracturing. If you are familiar with well drilling, there is where you talk about the common things that you always hear about: pore pressure, fracture gradient. So these are very common. Geomechanics is not something new, but applying it in EGS, it is especially critical. Now, this is a very quick one. Now, we're going to look into this geothermal gradient. We are looking into drilling deep, right? Now, at least we want to hit at least 150 degrees, else the, what do you call it, the heat exchange is not sufficient for you to actually produce your temperature, right? Now, we hope when we drill deep enough in that part of the rock, you have this natural pathway for your water to flow. So, of course, porosity, permeability, these are things we are looking at. What we want to do, we inject water into it, absorbs the heat, and it becomes steam and we produce it. Now, this is what we want. Then, moving forward, we have a lot of different fracture types. I'm not going to go into deep geology, but what I'm going to talk about is now, how do we ensure this fracture network is connected? So, in a lot of the places that we see in Taiwan now at the moment, the 3G exploration is still very sparse, I would say. We have identified a lot of hotspots around the country, but now going into the area, now it's much more specific. Much more specific and... Hello? Yeah, much more specific. And then now, how are we going to develop it to EGS? That is a really key question to ask. So what we want is the one on the top, right? Is the one on the top. So we want higher permeability. I'm not going to go through every point. I think the first one, the higher permeability. We want the connection to be there. We want the steam with the water injected to absorb the heat and be produced. Of course, now the problem, we might see low to no permeability. Now, of course, if you have anything from open fracture on the top, You can just start developing EGS, but here what we're going to talk about is we will require fracturing. And for us to do fracturing, that is because there's low to no permeability. And to plan your fracturing, which direction, how should you drill, that depends on your reservoir characterization. And then taking one step backwards, how do you characterize your reservoir? Your 3G survey. And then here today I'm going to talk about the wireline logging tools that's applied into it. Now, so just to repeat myself a little bit, so now what we want to do is, I don't really like to use the pointer. Let me just walk around. I like to walk around the room. Now, looking into here, right, this is a very simplified version of the EGS well design. It could be looking like drilling from two different well heads far apart. It could be any design that would you could put it in the same path parallelly going through it. So that's not important. The important part is what we want, the fundamental to it. One injector, one producer. That's it. That's the fundamental of the design. Now, connecting, that's the next question. So, actually, I brought this with me here. Now, going straight into the tools. Now, when we drill a well, it is not recommended that you start your well design. Yes, this is my well. I'm going to drill laterally, and then the next well will go laterally. Planning is easy, but number one, how are you going to plan it? Where you start drilling, which direction of azimuth you should go. Now that's the question. Now here, why borehole logging is important. You have your 3G survey, you had a general understanding of your reservoir, but when you go into the finer details, that is what is important. Now, just a very quick one, we're just going to talk about like this. I group it into three different points, but the fundamental to it is that the wireline logging should be done before you start drilling the lateral section. You can plan it, but are you sure you should drill this direction or this direction? Now, since the direction is important, let's look at it why. Now, before I go into the why, let me just talk a little bit on the tools that during our logging, what we want to do is log the vertical section first. So we see the first point out to ensure it hits your target depth. That's fine. Now there is a point here called faster tool deployment and reducing high temperature exposure. Now this is the tools that we use. There's always a temperature threshold that you can take from the ground. Now of course when you drill you hope to hit the hotter rocks, but not all tools can. Now this goes off. Hello? Okay, so not all tools can survive more than 200 degrees for a long continuous time. But of course, the tools in Halliburton, we are qualified to, again, I hope you can hear me. So our tools are qualified more than 200 degrees, right? Which is actually sufficient for a lot of the operations. But why is it faster to do a vertical section? Actually, it's very simple. Because we are just relying on gravity to pull the tools out. We can get the tools quickly down to TD, recover it up quickly, so that we ensure accuracy in the measurement. We also ensure our survivability of the tool. So these are things that you need to think about. Now, while you are drilling and you complete the TD, you still have some mud cooler remaining in it and still in effect. That will ensure the temperature that is lower, which means you are still able to use your tool even in the deeper section. Now, I'm going to skip all this. Now, the key part is here. When we log, we have this, we can come out with borehole imaging, micro images, etc. The idea here is to understand the fracture strike and dip. Now, this is the key when you want to plan it into an EGS well. For the geologists in the room, you'll be familiar with the Rose diagram. So this is going to tell you, what is the direction of strike, what's the direction of your dip, and from there, what we want to know is where is your shear. If I'm SH, I think it's shear, horizontal shear. Where is the maximum direction and the minimum direction? So of course, if you are in the drilling part of it, my background is geology, and I'm in the exploration geophysicist for quite a number of years. Now I'm going into drilling. So it helps you in planning your well. Where you're gonna set the casing, what's the mud that you want to use, the weight of the mud, etc. You want to make sure that you do not have any collapse and stuff. Those are under drilling, right? Regardless whether you are in oil and gas, geothermal, whether you're drilling a hot spring well, water well, these are standard. But what we want to move into is to understand the direction, the tensile fracture direction. This is something that is important. So how much, what we want to know, two things from here: the pressure that we need and the direction. So two things here: pressure and direction. So let's keep this in mind: pressure and direction. This is what we want to do. Okay, now when you plan your hydraulic fracturing, now we are talking about more on geomechanics of it. We are talking a lot on this imaging that the wireline log gives you. So now the idea here, I like to stand in front here because I like to use my hand. Now you have this thing here, right? You have different direction that you see. Now this will tell you your azimuth of your lateral direction should go this direction or this direction. You can plan, yes, based on the early understanding of the subsurface, the geomechanical study, the simulation. You probably have planned the direction. But until you see it, until you measure it, until you core it, that is still questionable. But this is always what we say in oil and gas, right? You never know until you drill it. So it's the same. In geothermal, you already hit your first objective through vertical section. You get the heat that you need. That's fine. But because EGS requires the connectivity of your fracture. Now, key point, connectivity of the fracture. If it's not connected, we need to artificially create it. That is through fracturing. Now, through fracturing, what is the most optimal direction? What is the most optimal pressure that you need? Because all these are equipments. All these are the operation side of it. That is where wireline is important. You have a 3G, you confirm it, and then you optimize and update your drilling plan and your well design through it. So now this is just a very quick, I would say just on a geomechanics slide, just to say what are we obtaining from the wireline logs. You know, you have like your DTC, you know, DTS, all this kind of stuff. At the end, I think what I want to really highlight, what you want is to know the Young modulus, positive shear modulus. This will help you to build your 1D mechanical earth model. I'm not going to go through all these kind of logs that eventually is operational, but what I want you to understand is the fundamental of why are we doing certain things and how we do it. So here, this is the important part of it. So after all your 3G survey, you understand you have a conceptual model, you have a simulated earth model. Now is to include your wireline information to build your geomechanical model. So here, that is where you understand and predict how would your fracture network look like. So with you drilling the well here, should you be placing the next well here, or should the next well be on the other side, or the next well should be on top of it? So that will depend how your geomechanical model looks like and how you simulate your what do you call it, hydraulic fracture model. So from there, you start to plan, you start to optimize. We can very importantly understand that you want to ensure the success and connecting the fracture network. That is the key point in all your EGS well. Now, just a quick summary of the tools. this is very simple. For those who you are in the wireline industry, those who are under drilling domain, you know that you have like triple combo, measuring your gamma ray, porosity, and density. If you look into wellbore image, definitely you have your micro image, your borehole imaging. Then of course your sonic log to actually define the weak plane and the geomechanical input study to the model. So all this is the preparation for the way forward. Number one, we need to understand your geomechanical parameters, right? How do you get that? You need additional logging, understanding of subsurface. You have your formation test and every stuff. Combine your regional geological information just to make sure that you plan for what I have on the top. Your okay, I'm trying to control my pointer. Your multi-stage hydraulic fracturing. How are you going to plan your staging for fracturing? Should you plan it at how many stages? What is the pressure? All those things, you have to come back to your data input, parameters, optimize your planning. Eventually, you get your hydraulic fracture done. Then, of course, after that, you have production testing. But for my presentation today, my message to you is do not underestimate geomechanical modeling. We understood that it is very important in drilling, but because we are developing EGS well, it is very important that it is used to ensure the fracture that you create connects. That is how you ensure the success of your EGS well. So I think that should be about 20 minutes of my time. This is my last slide, and thank you for listening. Yes.
Thank you. And
hang on, is there sufficient data resolution using LWD tools while drilling to get the triple combo sonic data, or do you have to use wireline?
Okay, so on the LWD, I think there are a lot of very good information you get from LWD, but it does not need 100% wireline to do it. But the other thing that we need to think of, if you want borehole image.
Well, you use downhole broadband to get wireline quality alongside your drilling.
We can. That's so I think the fundamental is here. Definitely during drilling nowadays we do LWD. So if that is sufficient, well, you can live with that. But of course, if you want to do high resolution, you need more data. Well, you go into wireline. I think the message, what I want to bring here is not really on the tools, but the fundamental importance of having the right data to actually build into your mechanical model.
Thank you.
Thanks.
okay. And any questions? Even you can raise your question, please.
So I think because of Taiwan, they don't have the physical log property data. So you use only the wireline. Probably have to recommend that we need physical testing of the geomechanics, like tensile state, compression state, and triaxial state. We calibrate the two. Otherwise, only the wireline log probably not going to be good enough, for the interpretation of the plan.
Okay, I hear you from here. Of course, this is just one of the tools that that we use to understand the geomechanical property of the rocks. Of course, the other things that we're going to look at is, are you going to do coring? Do we have core testing in the lab? So those are the things that we do need, but it's just that on this presentation is focusing on the tools from our wireline department. Of course, I definitely will not discount the importance of coring, lab mechanical tests. So those are equally important. So the key here is the more information you have, the better understanding you have, the better you can plan.